to give you a quick recap. In the last lecture, we talked about the mean, median, and mode, and we discussed the properties of each of these different kinds of averages. And we also talked about the fact that whether you calculate the mean, median, or mode depends on two considerations. And so one of them is the NOIR consideration, N-O-I-R. That is whether or not the variable that you're measuring, the variable that you're analyzing, was measured on a nominal scale, an ordinal scale, nominal, ordinal, interval, or ratio. And ideally, if we are recording dependent variables and we're going to analyze them later, ideally we want them to be on an interval or ratio scale. And that's because if we do measure variables on an interval or ratio scale, we're not limited to which math we can perform on those numbers. All right, so if you have interval or ratio data, you can calculate the mean, median, or the mode. Whereas if you have ordinal data, you can only do median or mode, and if you have nominal data, you can only calculate the mode. And as far as researchers go and everything, we don't want to be limited by our math, and so we try, when possible, to design studies and experiments where the variables that we record, that we later analyze, are going to fall on either of these two scales. All right. So that was one consideration. And the second consideration, in terms of which one you should choose, depends on the shape of the distribution. And we only got as far as talking about the normal curve. So if we plot down here on the x-axis are all the values, possible values of our variable, and the y-axis, which you cannot see because it's hypothetical here, but these are frequencies, all right? So we know the number of people who got each score. In a case like that, then if we're talking about the normal distribution, the hypothetical distribution that is perfect, the mean, the median, and the mode would all equal the same value. And do you remember what that value is? What number would they be? Well, if this goes from negative infinity to positive infinity, what's in between? 0, right? So if we're talking about the hypothetical normal distribution, mean, median, and mode would all be equal to 0. And so, we said, well, in a case like that, you would still want to choose the mean because later on you can do more calculations. If you did use the mean, report the mean as your average rather than median or mode. Of course, in the real world, we're not going to get data that looks exactly perfect like this. And so the mean, median, and mode are going to be different from each other. So our data can have this basic shape, but we would still expect these to be off a little bit, okay? They wouldn't be identical. And in a situation like that, it becomes even more important to choose the mean. All right, now, we didn't get any further than this. And so what I want to do today to close up this chapter is I want to talk to you about why we would want to choose the mean. Why is the mean the preferred measure of central tendency? And when would choosing the mean not be a good idea? All right, because it's not always going to be the case that the mean is the most representative number. All right, it's not always going to be the case that it's a typical number. So we're going to look at that, and then again we're going to elaborate a little bit more on why the mean should be chosen if at all possible. And then after that we're going to start chapter 4.